guesses. What are you guessing? Huh? 48? All right, anybody have something lower than 48? What'd you guess? 30? Is 30 our lowest guess? Okay, higher guesses. 96? 63? 80,000? Okay. What was your guess, Riley? 90? 300? Okay. What do you think, Lakeland? 128? Okay. Does anybody else have anything that's outside of this? Or we? All right. Okay, so most of us are guessing over here, 90 to 300. Evan said 80,000. So let's see. All right, figure it out. So I'm going to draw the first few stages. And I'm going to make myself a table. Stage. Feeds. So you would have one person. Oh, here's the question. I may have counted that as stage 0. There's one person. I think I did that. It doesn't change. It wouldn't mess up your guess that much, I'm sure. All right, so the first stage you'd have 3 people, and then each one of those. The second stage you'd have 9 people. So keep doing that. Now, eventually you're going to run out of room for drawing this, right? Because, you're going to have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. All right, so that is 27. So eventually you're going to run out of room to draw your tree. But what do you see happening each time? Multiplies by 3, so 4. Okay, 81. Well, it asks for the 10th stage. So 7. Oh, wait, I think you doubled that, Caitlin. You doubled instead of tripling that, 243. It should be 729. Ooh. 59,000. So Evan was the closest. He overestimated. But as I already knew, Evan is not a typical student. Students never guess that high, usually. Most students guess like you guys were guessing. Usually like 1,000 is the biggest guess I ever get.
Well, that changes today.
But it's actually 59,049. And that is just in the last level. If we wanted to know the total number of good deeds, we'd have to add all of these together here, but we're not going to do that. So almost 60,000. So this is a wonderful example of exponential growth. This is a good example of how things go viral. Hunter's always wanting to go viral for something, and he'll have like 40 views, and he'll be like, "Oh, he's almost viral," he thinks. But this is a good example of how things go viral, because if you watch a funny video and think that's hilarious, I need to send it to my 3 closest friends, and you send that video to your 3 closest friends, and they send it to their 3 closest friends. Yeah, it's not going to be perfect, but that's sort of how it really takes off, because a lot of times there's not like a rule you got to send it to 3 friends. Somebody might send it to 10, somebody, and it just like takes off, because if you spread it and then other people spread it and then you spread more and more and more, it will really take off. Mm-hmm. Yeah. So Evan's actually really close if he's thinking about the total. Yeah. Yeah, so this is, I always love doing this right here, because with the exception of Evan, who is not a typical student, with the exception of Evan, students never guess that it's going to be that high. So if you could conduct this particular experiment like this boy's idea, and everybody really did this, like everybody actually participated and did do something big for 3 other people, then that would make a big difference in the world, right? Because that would be like 60,000 people participating. The thing is that it usually does not. People, like chain letters, people will not participate to that level. But if they did, it would be an excellent idea. So let's think of some different ways of dealing with this, okay? What about if we only have 2 good deeds for each person? So same scenario, but just 2 good deeds. You can use a calculator. Yeah, you don't have to guess it. I've kind of got the main thing I wanted you guys to recognize there is, like, lots of people don't understand exponential growth and see just how fast things take off. Okay, what'd you get, Evan? 1,024. All right, so you could make yourself a table where you've got stage and number of deeds. So 0, 1, 1, 2, 2 would be 4, 3 would be 8. So you could do the table like this, but probably if you're like me, you're like, I would really like a faster way to do this, right? So you could just keep multiplying. You could do 16 times 2. There's the 5th, 6. Oh, wait. Times 2, 6, 7th, 8th, 9th, 10th. So that works. 1024. Is there a way we could get the answer right away? Like a one step, we could type one thing into our calculator. What do you think, Evan?
See that button underneath the clear?
Yep.
Let's do, like, for example, 9. Press that button.
Like that?
Yeah.
Okay, that gives you a big number, but it doesn't give you 1024.
2, that button is
10 to the second power. 2 to the 10th. Because think about what we're doing. We start off with one person, and then we're multiplying it by 2 for the next stage. And then we multiply it by 2 for the one after that. And then by 2 again, and 2 again. So it ends up being 1 times 2 10 times to get to that 10th stage, right? So that would be 1024. Okay, what do you think if you do 4 good deeds for each person? You still start with 1 person, but you're multiplying it by 4 to the 10th. Alright, so you would get 1,048,576. We should. Okay. Alright, so, let's think about this situation just a little bit more and then we'll get into our notes. So, a group of 5 friends decides to start a pay it forward process. In the 0 stage, there are 5 students. Each student does 2 good deeds for another student. Each of those does 2 good deeds and so on. So, this time our table would look different. We've got 1, 2, well, let me spread those out a little bit. So, what's happening, we got 1, 2, 3, 4, 5, and they're each doing 2 good deeds. Okay, and then each one of those would do 2 good deeds. So, what do you guys think? What do you think, Evan? Well, 2 to the 10th is going to give us this. Okay. Alright. Okay. Would that make sense? Right? You start off with, so basically each friend is doing their own separate one. So if 2 good deeds gave you 1024, if you have 5 people doing that, it's going to be 5 times that. Or if you think of the table, this time, stage, deeds. So you start off with 5 people. So in the first stage, if you multiply that by 2, you would have 10. And then in the next stage, if you multiply that by 2, you'd have 20. In the next stage, you'd have 40. So what you're doing is you're doing 5 times 2 times 2 times 2 times 2, so on for each stage, right? You're multiplying by 2 for each stage. So you would have 5 times 2 to the 10th power, which would be 5,120. So if I want to write an equation for this situation that would give me the number of good deeds at any stage. So if I wanted to write like y equals, and I want an equation that will give me the number of good deeds for 3 or 10 or 15, no matter what. Okay, so instead of putting 10 there, we could put x, and that could be any stage that we wanted to do. All right, so if we want to know how many good deeds are in the 5th stage, we would just do 5 times 2 to the 5th. So 160. So we could have done it this way all along if you already knew how to do it, right? These are what we call exponential equations. The reason they are called exponential equations is because your variable is in the exponent. Okay, so your variable is in the exponent. We haven't really looked at them yet, but we're going to look at some equations that look like this. Y equals x squared. Is that exponential? Is your variable in the exponent? You have an exponent, right? You have an exponent right there, but is it a variable? It is not. So this right here, this would be exponential. This is not, because this is not variable. What do I mean when I say variable? An x, or a letter of some sort, right? Okay, so exponential equations are so cool and can be used for so many different things. So let's look at some problems with these. So now we're looking at your notes. So that was sort of like my intro to this. So now we're looking at your notes. We're going to look at, for several days, we're only going to look at exponential growth. Then we'll come back around and look at exponential decay. Okay? So, it does not. It does not. Yes. Well, it's going to depend on how fast we get through this stuff. So, let's stay on task. All right, so your equation for exponential growth is going to be of the form y equals a times b to the x power. And in this equation, a is your initial value. So it's the number of friends you start with, right? In that last one we were looking at, it was that 5. You started with 5 friends. B is your growth factor, which is going to be 1 plus the rate. And X is the amount of time. Now, in that example we just looked at, we didn't have a set amount of time, right? We had like stages, which might not be all the same set amount of time. And other things we're going to look at, like compound interest, it will be a set amount of time for that. So let's look at an example. Ty has $4,000. He invests in a mutual fund that earns an average of 7% compounded annually. And that should say 7% per year. Compounded annually. Or sometimes I'll use APR. That is annual percentage rate. And sometimes, like in this problem, I forget to put APR or per year. But assume, unless I tell you otherwise, that the growth rate is an annual rate for investment sort of problems. I just forget to put it in there sometimes. So we want to know how much money Ty's going to have after 7 years. Okay, so the way we set up these equations right here, it's a lot like sales tax, right? Because when you earn interest, how many of you have a savings account that you put money in and it earns interest? Okay, so when you have money sitting there in the bank, right, the bank is paying you a certain percent to use that money. Hello? Yes. Here we go. I'll let you as well. I'll give you. All right. So what's happening if they if we just do simple interest, we would just take 7%, multiply it by 4,000, and multiply it by the number of years. But banks do not typically do that. They typically compound it. We're going to look at it compounded annually because it's easier. When you get to some of the upper level maths, you will look at compounded monthly or weekly or daily and things like that. But what happens is it's a lot like sales tax. What they're going to do is they're going to take $4,000 and they are going to let you keep the 100% of your $4,000 and they're going to give you an extra 7%. So that would be 1.07, much like sales tax, right? Except for you're not paying this money. It's the money in your account. And so at the end of the year, you got $4,280. So then the next year, if you leave your money there, if you don't do anything with it and don't take it out, then they're going to give you they're going to give you an extra 7% of that amount. Now your principal is a little bit more. The principal is what we call the amount that you have in your account to start with. So I'll have 4,280, and I'll multiply that by 1.07. So how much money did you make the first year that your money was in the bank when you went from 4,000 to 4,280? $280, right? This next year, if I take this and subtract the 4,280, I actually made $299.60. I made a little bit more money, right? Because I had more money in the bank for them to give me 7% of, right? So this is the way that banks are going to find this, but we can just use this formula right here. So what's happening is we're taking 4,000. That is our A value. That is what we're starting with. And we're going to multiply it by 1 plus the rate I should put right here as a decimal. So for this number right here, I'm doing 1 plus 0.07. So I get 1.07. And then I'm going to raise it to the power of 4 because he is going to leave it there for 4 years. So in your calculator, to do that power, you're going to do 4,000 times 1.07. And then to do the power, it's the button above your division key right there. I call it the to the key. And you raise it to the 4th power. So at the end of that 4th year, Ty would have $5,243, and since this money, let's round it to 2 places, 18 cents. So, in 4 years, Ty has made $1,243.18 just for his money sitting there. Right? He didn't work for that money. Now, I will give a disclaimer that 7% is a really good interest rate, and you're not going to get that on a savings account. My savings account gets like 0.5% right now. Savings account rates are not good. But a mutual fund is going to have a little bit better return because it is going to be invested in the stock market. If the stock market is doing well, it could be even higher than that. If the stock market's not doing so great, you actually can lose money, but we won't get into it too much. Trust funds, I'm not particularly sure what those are. If things are invested in stocks, you can lose your money. So a mutual fund, I am a little more familiar with that. Mutual fund, trust funds are like something where it's like you can't get to it to a certain age. Mutual funds is invested in the stock market, but it invests in lots of different stocks. So you have you put your money into this account, and then that money gets invested in like lots of different stocks. So it might be that your Walmart, Walmart's not doing good, but Amazon is, and then I'm just throwing some companies out there. It could be anything, and that sort of evens out. So they are a lot safer. They're going to follow the market in general instead of one particular thing. Whereas if you put all of your money in Amazon stock and then Amazon starts doing badly, you're going to lose a lot of that money there. So we'll particularly be focusing on things like savings accounts because savings accounts are very safe. They don't give you a high percentage because they are very safe. The bank has to give you your money back. There's no risk there, right? Up to a certain amount, it's FDIC insured. They have to give you the money back when you want it back. Stocks, you can lose your money. So you also could gain a lot of money if it works out for you. Okay, so let's suppose that Ty's parents had put $4,000 in an account gaining 7% interest compounded annually when he was born. How much money would he be in the account by the time he was 18? Okay, so this is really the same question again, right? Our principal amount is still $4,000. We're growing by 7%, so we do 1.07. And then this time we're going to raise it to the 18th power. So, I change this to 18 down here, we get $13,519.73. So you more than triple your money if you can leave it in there for 18 years. The longer you can leave money invested, the better. That's why they tell you to save for retirement while you're young, because your money has more time to grow. Problem is that you don't have any money whenever you're young. Because you don't. What do you mean, like for presents? Oh.
I don't know if it was the way my grandparents thought, but they like said, and it was also for my dad too, like they thought it'd be a good idea to set up savings bonds. And so my mom and dad would like flat out broke when they were like
Yeah.
and stuff. And so it was like, oh my god, a savings bond is like $25 we can buy pizza with this.
Yeah. It was a good idea there for a while because there was a time where they were like had really good returns. So like lots of people were doing that because I would get them for Christmas. But that is no fun because if you get a savings bond for Christmas, like that means that your grandparents paid $100 for this savings bond, and in like so many years it's going to be worth $200. So you need to wait till the thing is worth $200. But it also means that your Christmas present, you got to wait 6 years before you get to do anything with it. So they're not immediately a lot of fun, but they are not a bad place to put your money depending on what returns they're given at the time.
Wait, so what if you had a savings bond for like $100 and you're like 3 and then you forgot about it until you're like 18?
Savings bonds eventually quit earning interest. So like when they hit their maturity rate, you need to just go ahead and cash them in because they're not going to gain any more interest after a certain time. So it depends on what they're like. I think depending on like what rate they have and what length of time it takes them to mature. There, okay. So you invest $10,000 in an account that gets 5% interest compounded annually. How much money will be in the account after 12 years? Okay. So when we set this up, what's my principal here? What's the starting amount? 10,000. What's my B value? What number needs to go in that second? 1.05. And what's my exponent for my time? 12. Okay? So I could do 10,000 times 1.05 to the 12th power. And I'm going to get 17,958.56. 58 right there. Just so we can read it. Okay. You guys get the idea with this? It's fairly straightforward. Okay? Alright, so a sample in a lab contains 25 bacteria. The bacteria increases by 150% each hour. How many bacteria are in the sample after 1 day? So parts of this are going to be still pretty straightforward. What is a little bit tough about this is the percentage is way off from what we're usually seeing for sales tax, right? So our principal amount, how many bacteria are we starting with? 25. That number goes right here. Then we're going to have some number, and we're going to raise it to a power right here. Okay? So to get this number, we need to do 1 plus our rate as a decimal. Okay? What is 150% as a decimal?
1.5.
It is 1.5 because we would take that decimal, we would move it 2 places, and we would get 1.5. So that would give us, when we do 1 plus 1.5, that would give us 2.5. That's the number that goes right here. Okay? Then we need a number for our exponent. This is typically some sort of time. They're asking us how much bacteria is in the sample after 1 day. So what would we plug in? 24. Very good. I thought somebody might say 1. But this is increasing each hour, right? So we don't need to put in days right there. We need to put in hours because it's increasing each hour. So we're going to plug in 24. Okay, y'all ready for this? It's going to go crazy because you raise something to the 24th power and it's crazy, right? So this is the way the calculator does scientific notation. So I'm getting 8.88 excuse me, 1784197 E10. Having that E10 is like having times 10 to the 10th power. Have you guys done scientific notation before? Have you seen? It looks like this when you write out times 10 to the 10th power. Okay? All right, so 10 to the 10th power would be 1 with 10 zeros, right? And when we multiply something by something with zeros, we have to move our decimal to the right 10 places. So I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually got an empty space, right? So my answer would be 88817841970. Bacteria. Obviously, I just made this problem up, but this is how bacteria behaves. It grows exponentially. That is why you can pick up just a few tiny little bacteria of strep throat whenever you drink after your friend or something. And then 24 hours later, you got a fever, you feel terrible, you can't swallow, you need to go to the doctor. Okay, questions? Okay, population of Elkin is 4,106. If the population grows at a rate of 0.4% per year, what will the population of Elkin be in 30 years? Okay, so what is our starting amount? Okay, all right, who can tell me what to put in the blank right here? What's my B value? Not 1.04. This is a percent. I must change it to a decimal, which means I've got to move that decimal 2 places. Means I got to put a 0 right there, right? It should be 0.004. Okay? And then that'll be to the 30th power. I made this up, so I don't know if it's accurate or not. Roughly accurate on the population, that's close, but I don't know about growth rates. It just depends. A lot of rural areas are actually losing population right now. Not far off, actually. You also may have like a lot of people moving away, like people moving to different places. What we're seeing in the U.S. right now is rural areas are decreasing a little bit and cities are growing.
Still growing.
And I spent the last 2 days in Raleigh, which confirmed to me that I am not going to be one of those people moving. There's some cool stuff in cities, but I get annoyed every time I go to one. There's too many people there. All right. Now, I did round this to 4,689. Why did I round that to a whole number? these are people, so whole person is the best thing around it too there. Okay? This is how population grows as well. Obviously, there are different things that affect population growth. So it's not going to be just like a constant rate usually for 30 years straight. But, you know, if everybody just has 2 kids, then if every couple just has 2 kids, then you're just replacing yourself, and population would stay the same, roughly. Technically, it needs to be 2.1 to account for, like, people who may not live to adulthood, but it'd be about 2. But if people have more than 2 kids, then that causes population to increase. If you have a couple and they have only 1 kid or have no kids, that causes population to decrease because they are not replacing themselves. So if you want population to stay the same, then you got to have, for each couple, you need 2 kids so that you guys can replace yourself. I'm replacing myself with Hunter and Henry. My husband and I, we're replacing ourselves. So we're keeping it constant.
I'm not sure if we need to keep it constant like we do right now, because can we support like 3.5 billion people?
We're going to talk about that, actually.
Or really?
We are going to talk about it. Some, I don't have an answer.
If China
But-
and California fell off like the impact of the earth, we'd be completely fine.
China's population is actually, oh, you're right, I did. There's actually a lot. All right, so economically, it is terrible to have population decline, because that means when you have population decline, it means you have a lot of old people and not very many young people. And the young people are the people that are working and are able to work, and then you got a bunch of old people getting old and sick all at one time and nobody to take care of them. Economically, it's really bad to have population decline. But environmentally, population growth can, stress the resources of the earth. So there's a lot of different things to talk about there that are interesting. We're going to look at a video.
China's got a major population decline right now.
Yeah, Japan is like the lowest in the world. In China, it's because they had a one-child policy for many, many, many years where there were like heavy taxes if you had more than one child. And so now China has they upped it to 2, and now they've upped it to 3. You can have 3 children, but people are not having more children. They like only having 1 child, and so they're seeing population decline.
Increased again, and they're just shoving people in rooms when they get COVID just to die out.
They definitely have some crazy COVID policies. Like when you get it, you have to leave your home and go to centers. I'm glad I'm not in China. They have at least came down off of some things there. Okay, so Roxana gets 2 rabbits for Christmas. In order for this to work, they need to be a boy rabbit and a girl rabbit. The rabbits reproduce approximately every 60 days based on my rabbit research. This is relatively true. It does not take long for a rabbit mama to have rabbit babies. It takes a human 9 months. Rabbits, a couple months, and then they're ready to go again. Yeah, so you got very little time between rabbit litters if they just run free. So, they're approximately every 60 days. If the number of rabbits triples every 60 days, about how many rabbits will Roxana have by next Christmas? Okay? So, she got her 2 rabbits for Christmas. 60 days later, the number of rabbits will triple. So, how many rabbits is she starting with? 2. Right, and then the 3 we're going to use. So, right here, they don't give us a growth rate for this. They just tell us triples, right? So we're just going to use 3 as that number we're multiplying by. Now, what power should I raise this to? What? 2 months is how long it takes, or about 2 months is how long it takes to have. So 60 days is every 2 months, right? And we're going from Christmas to Christmas. So we're looking at a whole year. So it's not going to be exact, but you'll have about 6 litters of rabbits during that time, right? Because it takes every 2 months, 12 months, half of that will give us 6. So to get a good approximation, we're going to raise this to the 6th power. Look how many rabbits Roxana's going to have. 1,458 rabbits. That's why you don't get a boy and a girl rabbit.
That's why you don't put them together.
Or don't put them together.
You put them together once and then after they have that litter, you separate them together.
Yeah. Now, this would have to be with no rabbits dying and you taking good care of all of the rabbits. If this was in the wild, this wouldn't happen, because in the wild, all the rabbits would not live. Coyotes would get them. Some would get run over by cars. Some would not make it, right? So,
I don't know the weird stuff about rabbits. My parents made me research for like a year before they let me get one.
Hunter's daycare, he used to have rabbits, and I think that there was some uncontrolled population growth of the rabbits, because he just let them run free during the day, and sometimes you would drive up and there would be 15 rabbits everywhere. But it was not uncontrolled population growth completely, because dogs and stuff would get them in. Whatnot. All right, so we've got about 15 minutes. You guys have a worksheet. This is going to be your homework. Hopefully this is making sense. This should not take terribly long amount of time, because you're doing most of it in your house.